Hello everyone. We are going to start with another lecture of performance management, and in this lecture we are going to deal with the past paper question of life cycle costing. Let's see what we can do. Let's start with this question. Let's see. Uh, see, its first requirement is simple. It says that calculate life cycle cost per unit. That is for 6 months. So let's just start with this part. Let's see what we can do here. Fit Company specializes in the manufacturing of a small range of high tech products for the fitness market. They are currently considering the development of new type of fitness monitor which would be the first of its kind which will be the first of its kind in the market. It would take 1 year to develop, with sales then commencing at the beginning of the second year. That means what? In the first year, we will this company will develop the product, and sales will start from the beginning of the second year. The product is expected to have a life cycle of 2 years before it is replaced with a technologically superior product. The following cost estimates have been made. So, in year one is basically research and development related year. Year two is operational year, and year three is also an operational year, right? So since the first year is related to R&D, therefore there is no production and sales. Units manufactured and sales in year 1 is 0, right? And in second year we will manufacture 100,000 units, and in the third year the company will manufacture 200,000 units. Then it says research and development cost is expected to be 160,000, product designing cost is expected to be 800,000, marketing cost is expected to be 1.2 million in first year, 1 million in second year, and 1.75 million in the third year. Variable, then it says manufacturing cost is variable manufacturing cost is around $40 in first year, $42 in the second year, and fixed production cost is 6,50,000. Then distribution cost is given, then selling cost is given, and then administration costs are given, right? So all these costs are given, and what you are required to do, you are required to calculate the life cycle cost per unit of the product, right? So I prefer that you may pause this video. You should pause this video and try to calculate life cycle cost per unit at your own, and then you may continue with this video, right? So pause this video, try to calculate the total cost of the whole life of the product, and then you can continue with this video, right? So let's do it in a shortcut manner, right? Let's try to calculate fixed cost first, right? Now, what is the fixed cost? Fixed cost is actually related to research and development, right? There is research and development cost, and that is around 1,60,000. This is one-time cost. 1,60,000 is the research and development cost. Then product designing is 800,000. Product designing is 800,000, and then marketing cost is 1.2 million. Marketing cost, let's calculate the whole cost here, and just a second. So total marketing cost will be 1.2 million for the first year, 1,000 for the second year, and 1,750 for the third year. 3,950, right? Let's calculate it in thousands, right? It's easier for us, right? What's next? Then it's manufacturing cost. We let's ignore variable cost. Let's consider fixed manufacturing cost. Fixed manufacturing cost is 650 and 1,290. This 650 and 1,290. So 650 plus 1,290. That makes 1,940. We can do it on Excel as well, but let's calculate it. Distribution cost is fixed cost 1.2 million. Distribution cost is 1.2 and 1.2, that is 2 lakh 40,000. And what's next? Selling fixed cost is 180 and 180. So selling cost will be 3 lakh 60,000. And administration cost is 200, 900 and 1500. So 1500 plus 1100, 2600. This is what? This is administration cost. Right? We add all these figures. Now, so the total fixed cost, I am pausing this video and calculating the total cost. So this is 10050, right? And then we will add variable cost. Let's try to have a shortcut in variable cost. See, variable cost of first year, variable cost of, and all variable costs are depending upon the number of units produced by the company, produced and sold by the company. So let's calculate total variable cost per unit first, and then multiplying with number of units. So $40 is variable production cost, and $4 is distribution cost, and $3 is selling cost. So we will manufacture and sell same units. So that means what? That means variable cost will be 40 plus 4 is 44, and 3 47. So 47 multiplied by 100 plus, it's recording now, yeah, plus 42 plus 4.5, 42 plus 4.5 plus 3.2, 49.7. So 49.7 multiplied by 200,000, right? So 49.7 multiplied by 200 plus, it's 9940. And this figure is 4700. So 9940 plus 4700 is 14640, is 14640. So total cost of the product, life cycle cost of the product is 14640 plus 10050, 24690. It's 24690. This is the overall cost. And what will be the cost per unit? Cost per unit will be divided by 300, right? So this will be 82.3, right? So this is basically cost per unit of the overall life of the product, and this is for 6 months. So there's a very simple, very easy requirement, right? The problem is not part A, the problem is with part B. What is in part B? See, uh, let's read this question. Let's see what's given in part B. Uh, After preparing the cost estimates above, the company realizes that it has not taken into account the effect of the learning curve on the production process. That means what? They forgot. They forgot to take learning curve effect. Now try to think what will be its impact. If you do not consider learning curve effect, then your labor cost will be overstated. Why? Because you will consider your labor to, I mean, you, if suppose first unit will require 2 labor hours, so you will consider that all units will require 2 labor hours. Although actual in practical situation, all units will not require 2 labor hours because labor is learning, right? That's basically the issue. So the problem is that they didn't take the they couldn't take account of this learning curve effect. the variable manufacturing cost per unit above. Now, what is variable manufacturing cost? Variable manufacturing cost is this one. See, this is manufacturing cost and this is variable manufacturing cost, right? So, variable manufacturing cost above of $40 in year 2. See this one. I'm trying to highlight this. $40 in year 2 and $42 in year 3. This one includes 0.5 hours of labor, right? The remainder of the variable cost, the remainder of the variable manufacturing cost is not driven by labor hours. Now try to think, what do you mean by this? See, I don't know if you guys can recall what is the concept of variable manufacturing cost, but see, uh, manufacturing cost means what? Manufacturing cost means manufacturing cost means direct material, direct labor, direct expenses, variable production overhead, and fixed production overhead, right? If you add all these figures, you will get manufacturing cost per unit, right? And what is variable manufacturing cost per unit? For variable manufacturing cost per unit, we will consider all the complete variable portion and we will ignore fixed overhead in that case, right? So that means what? This is variable manufacturing cost. Now, try to concentrate here. The question says that variable manufacturing cost per unit includes 0.5 hours of labor cost. The remainder of the variable manufacturing cost is not driven by labor hours. That means, see, material has no connection with labor hours. Sometimes expenses don't have any connection with labor hours, and variable overheads may not have some connection with labor hours if variable overheads are dependent upon machine hours. So the question is saying that, look, complete variable cost is not dependent upon labor hours. There are some certain elements which are not dependent upon labor hours. So so they are saying that this whole 40 is not is will not have an impact of learning curve. Only labor related cost will have an impact of learning curve, right? So the remainder of the variable manufacturing cost is not driven by labor hours. The year 2 cost per hour for labor is 24, right? The year 2 labor cost per hour for labor is 24 and year 3 cost is 26 per hour. Now, if the question is saying labor cost per hour is 24 and 26, this means what? These two figures are actually the wage rate of labor. How can we say that this is wage rate? Because this is per hour, right? This is not a per unit cost, this is per hour cost, right? Subsequently, it has now been estimated that although the first unit is expected to take zero point 0.5 hours, learning curve of 95% is expected unless 100th unit being completed. That means first 100 units will be affected by learning curve, and after 100th unit there will be no learning curve. There will be a steady production time will apply. Now what you have to do? Calculate the revised life cycle cost per unit taking into account effect of learning curve, and this requirement is of 10 marks. So it's a huge requirement, and to be very honest, first part is not a problem. Fourth, C part is not the problem. Problem is B part. So you have to concentrate on B part. But again, I think that you should pause this video and try to think, because see, thinking is really very important. If you are thinking on the question for the question, that's really very important. So try to figure out that what can we do if we want to calculate revised labor cost, revised life cycle cost per unit of this in this particular situation. Pause this video, think. See, the situation is simple. This is the complete cost of the product, right? This is 24690 is the current total cost, and in this current cost there is a issue of labor cost. So we will try to calculate the correct version of labor cost, and then we can plug in that cost in the overall life cycle cost of the product. So this is basically what we need to do. Now, how we will calculate the revised cost? That's also a very important question. Think. See, it's important. Learning will only apply on the first 100 units of the product, right? On the first 100 units of the product, only learning will apply. That means what? That means you can apply learning curve formula for the first 100 units. And what about any units then after? Any units over and above 100 units will take exactly the same time as of 100 unit, right? So this is basically the situation. Now, how can we do this? Let me try to write those a step first. First of all, what we have to do? First of all, we have to calculate total time required from 1 to 100 units, right? This is the first step. Second step is we have to calculate time required for 100th unit. And how we calculate time required for 100th unit? We calculate it by total time of 100 units and taking the difference between total time of 100 units and total time of 99 units. And in the third step, we will calculate the remaining time required for remaining output. Time required for remaining output. And what is the remaining output? See, total output is 100,000 units in year 2 and 200,000 units in year 3, right? So 100 and 200, that makes 300,000, right? Sorry. That makes 300,000. So 300,000 minus 100, sorry. 300,000 minus 100 units is equals to 29,900. So remaining output is 29,900. Sorry, 299,900. Right? So this, we have to follow this strategy. Right? But there is one more issue in this. Issue is labor cost of first year is 24 and labor cost of second year is 26. So what we have to do, we have to calculate labor hours of both years separately. If we calculate total labor hours in a single figure, we will not be able to calculate labor cost because wage rate of both years are different. So we have to calculate labor hours of both years separately, right? So we will do it later when you're required to do so. Right now we are trying to start with the first step, and the first step is what? The first step is to calculate time required for 100 unit, right? So remember the formula. What is the formula? Formula is, let me try to change the posture a bit. Okay. How can we calculate time required for 100 units? It's simple. Y is equals to what? Y is equals to ax raised to the power b, right? So if you want to calculate total time for 100 units, then y is equals to a is time required for first unit. First unit time is 0.5 hours, right? So we will write 0.5. This is 1 to 100, right? 0.5, how many units? 100 units. And value of b is this, minus 0.074, right? So let's try to calculate this. I hope this calculator works. 100 raised to the power 0.074, and this figure is in negative, right? And then multiply by 0.5, 0.355. This is 0.355. And this is what? This is the average time. For total time, you have to multiply it with 100. So total time in this situation will be 35.5 hours. Right? Let me try to zoom this figure. Oh, sorry. Okay. So y will in this case will be equals to 35.5 hours. Not y, sorry. Something is wrong here. It's not y. Total time in this case is equals to 35.5 hours. Right? So this is the first point. We are done with this. For the second calculation, we know now we know that total time required for first 100 unit is 100. Now what we have to calculate? We have to calculate time required for 99 units. So we will apply the same strategy, we will apply the same formula. Y from 1 to 100, 1 to 99. This will be what? This will be y is equals to ax raised to the power b. So y will be equals to 0.5 into 99 raised to the power minus 0.074. So y in this case is equals to what? 99 raised to the power 0.074, right? And we keep it in minus, right? And then multiply it with 0.5. And then multiply it with 99. 35.231. 35.231, right? So this is not ty, this is time. Right? So what will be the total time for 100th unit? What will be the time required for 100th unit? 100th unit time will be 35.55 minus 35.231, and that is equals to what? 35.55 minus 35.231. It's 0.319. 0.319. This is what? This is time required for 100th unit. Right? Now, the remaining output will require exactly 0.319 hours per unit, right? So, acha, now what we need to do? Now we need to do some different thing. Now we have to calculate total time required for first year. Right? Now we are calculating time for first year. So, time required for year 1. And how many units are in year 1? 100,000 units. Right? There were 100,000 units. So, acha, out of these 100,000 units, we have calculated time for 100 units, right? We know that first 100 units will require 35.5 hours. So what is the remaining output in the first year? Remaining output is 99,900. So time required for 1 to 100 units is 35.5. Time required for 99,900 units will be multiplied by 0.319 and multiplied by 99,900. 31868. 31868 plus 35.5 plus 35.55. It's 31904. It's 31904 hours. This is what? This is time required for year 1, right? And this is a very important figure. Let's try to highlight this. This is total time for year 1. Now, what will be the time for year 2? It's very simple. Time required for year 2 will be, how many units are in year 2? There are 200,000 units in year 2, right? So, Time required for year 2 will be 200,000 multiplied by same 0.319 hours. 0.319 hours, that is equals to 0.319 times 200,000, 63,800. 63,800 hours, right? Again, let me try to highlight this figure. It's an important figure. So finally we got number of hours, but we have to calculate labor cost now, because we are supposed to calculate revised cost per unit of the product, right? So for revised labor cost, we have to calculate the wage rate. We have to calculate the cost. And what is the cost? Cost for the first year is 24, cost for second year is 26 per hour, right? So we will multiply this figure with 24, and we will multiply this figure with 26. So 24 multiplied by 31904, 765,696. Let's consider it 766,000, right? And this will be 26 multiplied by 63,800. I think there is some sensitivity issue with this screen. It's 1659 and 000. So what will be the total revised labor cost? Revised labor cost will be 1659 plus 766, 2425, right? This is the new labor cost. Now this is again an important figure, right? Now we have to plug in this cost into the total life cycle cost of the product. It's 2425, and where is that cost? 2425. What is the cost? The cost is 2425, right? So 2425 is the cost. Now this is basically cost which we have calculated in part A, but obviously this is not a correct cost, so we need to exclude the labor cost from this figure and include we need to exclude the wrong labor cost and include the correct labor cost, right? And how can we do this? See, life cycle cost of the product, life cycle cost of the product is 24690, right? Let me write it here, 24690. What is the original labor cost? Sorry. What is the original labor cost? Original labor cost is for year 1. In year 1 we have to manufacture 100,000 units, and there are 1 unit requires 0.5 hours and wage rate is 24. And in second year, you may pause this video and check the facts and figures. Actually I have a problem with zoom in and zoom out here, so I'm not, yeah, okay, fine, let's try to do, okay, fine, we did it finally. So second year it's 200,000, this figure, 200,000 multiply by what? Multiply by 0.5 and then multiply by 26, this figure, right? So this is the current labor cost. So we have to deduct this figure, right? And what we have to add here, we have to add new labor cost. Not new, it's better to use revised labor cost, which is 2425, right? So this will be the revised life cycle cost of the product, right? This is the total revised life cycle cost of the product, right? Let me try to calculate this. I hope I can do this. Sorry. 100,000 multiplied by 0.5 into 24 is 12 plus 200,000 into 0.5 is 100 times 26, 3,800. So we have to deduct 3,800 from this figure, right? We have to deduct 3,800 and we have to add 2,425. So 2,4,690 minus 3,800 plus 2,425. 2,3,315. 2,3,315. So this is the overall life cycle cost of the product, and revised cost per unit will be equals to 2,3,315 divided by 300. So divided by 300, 77.7, right, per unit, right? So this is basically its second part was bit difficult, and to be very honest, I personally believe that there will be few students. I mean, I personally believe that those students who were present at that time, few students would have been able to complete its second part. It was a difficult part. C is simply the benefits of life cycle costing. So I'm leaving this part at your own. I mean, this is for 4 marks, so you just need to identify two basic benefits of life cycle costing. That what can be the benefit? For example, we can include complete cost. We can charge complete cost from the product because life of the product is short. For example, like in this question, as we can see, because question related, if you give any example related to question, it's usually considered to be a better option. So as we can see that these costs are actually related to this product, so we must charge these costs from the customers of who are buying this product. So if you use life cycle costing, then we can charge these costs and all these directly attributable costs from these 300,000 units which this company will manufacture and sell during the 2 years, right? And second benefit can be that since we know the life cycle of the product, so we know that what are the ups and downs of the product, right? So we know at what point we should increase the selling price and what point we should decrease the selling price, which areas advertisement is important, in which areas advertisement will not play a crucial role, where you should try to advertise to beat the competitor. These kind of things are very 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 helpful in life cycle costing, right? So that's the end of this video. Thank you for watching this. Have a nice day. Allah Hafiz.